Hey, what's going on, guys? Coming again here. In this video we're gonna drop a player into our game world, make it moving along the angle that is actually representing the direction of where exactly the player is moving to, and implement the wall collision detection. That's pretty it. But before we start, let's actually have a look how the game that we're developing is gonna look like at the very end, just to keep your motivation. Okay, so the very first thing I want to do before I forget, let's actually move this screen width and high definition just right over in here after the canvas has been initialized. It's just a better place for it. And now we are going to define our player. So there would be a plenty amount of variables, but let's go step by step. So the very first thing to consider is player X coordinate. Okay, so we'll place the player at map scale, which represents the width of the tile that our array element is getting scaled to. So in our case, now it's kind of 10 pixels. Eventually would be 64 pixels to match the width and height of the texture for Wolfenstein 3D. And let's give just a small like offset of 20 pixels. So for current map, it might not be the best ever solution, but when the map scale would be 64, it would be just fine. So the next thing to consider is player Y position. So player Y is going to be equal to, map, same thing. So map scale plus 20. And now player angle, we'll make it equal to math.pi. So we're calculating, we're using radians here, not degrees, and divided by 3. So this is just this sort of a variable. Yeah, it's not a constant, it's a variable. It's just a matter of where initially the player is gonna be facing. So this is the player, and this is where it's facing. So I will now draw this on the map so it would be crystal clear, and I'll show you how changing this value would be changing the direction. Okay, we'll need a few more variables to implement the non-blocking multiple button presses. Like, so we can not only move like forwards or rotating, but so we can kind of press forward button and left button, and we're just going like this, or forward and right, and we're going like this. So we'll need a few more variables here, but we'll define them later on. Now let's go back to the map and make a bit of a refactoring here. So I want to get this entire thing, and let's call it map offset X, because we're going to be using this variable quite pretty a lot. So map offset X, and just define a variable here, map offset X would be equal to this sort of a thing, and here map offset Y, control X, map offset Y would be equal to variable map offset Y equals to this thing. Okay, and same here. So this would be map offset X, and this is going to be map offset Y. Okay, map offset Y, and now we can make it one line. Okay, great. So let's have a look at the output just to make sure we didn't break anything. Okay, so let's make sure that there are no errors. Okay, no errors, brilliant. Okay, so now it's time to draw a player. So yeah, let's draw a player. So we're going to be using this kind of like circle to represent a player. But before that, we need to define, just to make our life a little bit easier, we want to define a few more variables. So I'll create a variable called player map x. So player map x, that is equal to player x plus map offset x. So all this is needed just to, so the real player x and the real map are like on the top left corner of the screen on our graphical kind of screen that represents the area where we're drawing everything. But bear in mind the fact that we actually want to have, so we have an offset for a map, so we just want to centralize the map now, and in order to properly draw the player, we need to take care of all of this offsets. And again, even though we're not going to be drawing a map when there would be the 3D world we're going to be walking within, still we will want to draw a mini map, and for that mini map all of this offsets would be on the cards as well. So it's really kind of useful to define all of these variables just to calculate the offset properly. So in when I was implementing this in Pygame, I didn't get bothered with this, but because I was drawing the map on the top left kind of like part here, and it was kind of done automatically because it was like the full screen mode, and just don't really want to talk about this here. So just to give you an idea that all of this things is really useful, and it's not just for debugging. It is for debugging, but it's not only for debugging, and we're going to be making use of this later on as well. So player map y is going to be equal to player y plus map offset y. Okay, and now we actually want to draw a player. So the very first thing to consider, we need to pick up the red color. So I can say context dot fill style equals to red. Okay, so we just took a red color. Then drawing circles is a little bit different from drawing kind of like rectangles. So we need to use the so-called path. And every time we're dealing with the path, we need to reset the path from the previous path if there was any. So in order to do this, we can just simply say begin path like this. And then to draw a circle representing the player, we can say context arc. So that's how we can do this. And now the player x and player y coordinate, but bearing in mind the fact that we need to take care of the offsets. So here's where we can use our player map x. So the actual coordinate where to draw the player. So player map x and player map y. Okay. And now to make it actually a circle, we need to define the radius. Okay. Then I'm not sure what this parameter stands for, but if it's not going to be equal to 0, it's just not going to draw the entire circle, but just a part of it. And here 2 multiplied by math.pi. But in order to increase the performance, we can just create a double pi variable. Okay, and let's say here down below the player, we're gonna be dealing with a let's call it camera. So one day, when it comes to field of view and variables like that, so it's a very nice place to put the constant of double pi right over in here. So double pi would be equal to this. Okay, and now if I did everything properly, should draw a red circle somewhere here. Okay. Okay, it doesn't, so let's have a look if there is an error. Oh, I just didn't actually invoke, I needed to say fill, context fill. Sorry for this, guys. So yeah, I'm still pretty new to this canvas element, so oh, sorry, not here. Fill contact, nope. And context dot fill. And this is needed to actually draw the circle. So here is the circle we have. Okay, so this is the player. Here we represent our player. And now we have a player angle, right? So player angle. So where in particular does this player is looking at. So here, where is it looking at? So, and here I would like to introduce the core math formula that I have no idea how it works, but this is the formula that we would be using to determine like the rays that we would be casting from the player end to the outer world. We're going to be using this formula to make the player moving along the ray angle, and actually to draw this ray angle, which which actually represents the direction of where exactly player is looking at. But before that, yeah, let's say we need to draw a line, and drawing a line is also not that trivial. I mean, like, it's not a single line of code like in Python and Pygame, but we need to say context dot stroke style. So we're going to be not filling but stroking in this case, so stroke style, and it would be red. So again, like specifying the color. I want this line to be the color of the player. Okay, then context dot line width is going to be equal to 1, so I want to make 1 pixel width. And then again, context dot begin path, so resetting the path like we did before. Okay, and now context dot move to, so this places like here we define the starting coordinates of where the line should start from. So like start x, start y, and then we will have destination x, destination y. So here we use this coordinates, so player map x and player map y. Okay, and then context dot line to, and this one specifies the destination points. And this is the most interesting thing. So here I can say player map x plus and math dot sign of the player angle. Don't ask me what this means and how exactly this works. I have no idea, but I know that this is gonna draw a line at exactly the direction where the player is looking at. And for y coordinate, we need to say player map y plus math cosine, in this case, of the player angle. And again, like, this math is going to be used all along the way within the entire raycasting algorithm. So it should be simple. Well, if I knew that how this works, it would be even better, but well, anyway. And yeah, and finally, in order to actually draw this, we need to stroke our line. So if I'm not mistaken, it should be something like context.stroke. Okay, so if I did everything properly, it should now draw. Okay, begin path is not defined. Oh, sorry. It now should draw a line. Nope. Okay. Okay, now just because I forgot, guys, so this value is extremely small, so we need just to multiply by a small constant, which would be defining the length of our line. So here is the line. So if I make this a bit bigger, like 10, let's say, yeah, then in this case we'll have a bigger line. Okay, and this already might give you an idea of how exactly we're going to be making the raycasting on it. So even though this is going to be the topic of the next tutorial, still, this is just the idea. So if we just increment this value by a certain amount, so the logic of how to increment this is the matter of absolutely separated algorithms. But just to give you an idea, so we can extend this line until it hits the wall. Then we will be matching the condition of the ray hitting the wall, and that's how we calculate the depth. And based on the depth, we would be drawing the walls either higher, taller if the depth is small, or we're going to be drawing like small height walls if the distance is longer. So that's pretty how it works. But again, I just wanted to give you an idea that these formulas, we're going to be using them all along the way, but for representing the player, this 5 is literally enough. And I will go into details on when it comes to the implementation of the raycasting. So we're going to be using some, like, not the most naive but a bit more sophisticated algorithm, but which saves lots of processing power, which is absolutely crucial, especially bearing in mind the fact that we're writing in JavaScript. So I hope that's clear. Okay, and now it's time to start moving our player along the map. So let's go for it. So let's define a few more variables below our player. So well, maybe not the best ever variable names, but let's call them player move x, and let's make it equal to 0. So this this variable, well, let me just define them first and then explain. So player move y equals to 0, and player move angle, yeah, so also equals to 0 for now. So when we press, let's say, arrow key up, we want to make this player move x being equal to +1. When we press key down, like arrow down, we want this to be -1, and then we're going to be multiplying player offset. So the destination for our player would be player x plus player offset x multiplied by the player move x, just to define the direction, whether it's moving forwards or backwards. And you might be wondering why those complications are needed, why we can't just define this offset like player x equals player x plus player offset x, and player y equals player y plus player y offset, or player offset y. And that's because of a blocking nature of key press events in JavaScript. So we want to press forward key and then the left key, and we want that it just starts moving like this or like this if it goes to the right. So we're just gonna be like switching on and off the directions of where exactly the player is gonna be moving, like either forwards or backwards. And also for the angle, so either would it be increasing or decreasing the player angle. So that's the way of how the direction is going to be handled. And now we want to handle user input. So handle user input. Here we'll define here we will bind two events. So the first one, I need to say document dot on key press, and okay, on key down, not on key press, on key down. And the callback function for this, so it takes the event, and here I just want to switch the event. So switch event, okay. And so just to give you an idea where I'm going to be taking the cases from, let's say console.log and event. Well, let's start from this one. I just really want this to be as clear as possible. So let's update. Okay, and now you see, like if I'm pressing the keys, keyboard, like key down event is being fired, and here we have key code. So let's see the key code. So key code, save, update. And now I'm pressing K arrow up, we have 38. I now press arrow down, 40. Now press arrow left and arrow right. So these are the exact cases for a key code that we're going to be using to handle the user inputs. I hope that's clear. So just to give you an idea where these numbers are coming from, we could have used the key name, or I don't remember how that is called, but it's easier to deal with integers, or yeah, I guess this is integers, maybe floating points, but I guess those are integers. It's just faster than comparing the strings, so just for the performance reasons. So here we have the case 40, and in this case we want to say player move x is equal to -1, and also player move y is equal to -1. Now you might be wondering, why do we deal with both? Well, that's because when it comes to collision detection, so I just don't want to the player stuck at the wall. I want the player slightly be like shifting along the wall, and for that reason we need both coordinates. So if one stacks, then another would still be kind of incremented. So how that's clear? Well, at very least it gets clear when it comes to the actual implementation. And now the next case is case 38, and here is the same but the opposite direction. So this would be +1, this would be +1. Yeah, don't forget to put break here. Okay, and now for the angle rotation. So case 37 would be equal player move angle equals to 1. Okay, and then break, and finally player like 39. Okay, case 39 and -1. Okay, so, and this only kind of sets the flag kind of to move either kind of forwards or backwards, or to rotate either to the one direction or to the other. But we also need to handle the on key up event, because we need so as soon as user drops the key, if it just stops pressing the key, we need this kind of direction handlers to reset them. We need to reset these direction handlers. So because otherwise it's just going to be running forever. Okay, so document on key up. Okay, equals to, so here I define another callback function. It also takes the event and the same thing. So I just can grab this, copy. Now it's the matter of just resetting the values back to 0. So here, so case forwards is the same as the case backwards, and we just want to make it 0. So just no longer not moving anywhere. Okay, and what else? And here either rotating to the one side or to another, like this. Okay, so it's not gonna cause yeah, let's just take this stuff. The player is not moving yet because just pressing the keys, but it's not moving yet because we didn't implement the very logic of how to move the player actually. So now we need to go to our game loop. Okay, so below the update screen and above the draw map, here we go. So the very first here we want to update player position. So the very first variable, so we need to define the variable called player offset x, and that's what I've been talking about already. So remember the formula that we've been using here to draw this this line. So this is kind of the destination point of the line, and when it comes to moving the player, this exact point becomes the destination point to replace this player point right over in here. So that's why we use exactly the same formula here. So okay, so player x is going to be equal to math dot sine and the player angle, like this. And now for the player offset y, we have exactly the same thing. So player y, but this time we use the cosine. So this target coordinate, so the player offset y is exactly the same as like player map x plus this one. So the one we want to have like where the player is moving along the direction. It's important that it's not moving like on the x coordinate or on the y coordinate, but it has the player angle, and when we push and when we press the forward button, it needs to go along the angle. So that's very important thing to consider. Okay, and now to actually make the player moving, we need to say if, and if player move x if player move x, is that the name of the, hold on a sec, yeah, player move x. So if this variable, if the direction variable is not equal to 0, we want to say player x plus equals player offset x, player offset x. But also we need to multiply this by the player move x, because the player move x is either 1 or -1, so we need to make sure that we're moving either forwards or backwards. Okay, player move x. Great. And now the same thing for player move y. So if player move y, then player y plus equals player offset y, and multiply by the direction player move y. And same for the angle. So I can say if player move angle, in this case player angle plus equals, and here we use the constant, so this is just the constant, which seems to be working nicely. Not too fast and not too slow, just somewhere in between. So multiply by the player move angle, player, so either to the one direction or to the other, player move angle. And if I did everything properly, it should already moving the character along the screen. So I hold my breath. Okay, player move y is not defined. Okay, player move y. Okay, player move y. Hope it's okay here. Okay, hold my breath. And okay, nothing happens. Okay, let's debug. Okay guys, I'm extremely sorry. Obviously we need to switch event key code and not the event itself. Really sorry for this inconvenience. Yeah, so we're switching the key code. I've been talking about this for so long and eventually forgot to do this. So yeah, let's have a look. Okay, now we're moving. I just made some debugging stuff here. Let me get rid of this. Okay, and yeah, let's go for, okay, so now we can move our player, but now it moves independently of the tile size, which is not really that great because we're going to be having the tile scale to 64 by 64 pixels. And if you remember that once we've defined the variable called the map speed, and this is the formula to calculate it. So to make the speed of the player relative to the map, relative to the square, relative to the cell or this kind of square size, we need to multiply by the map here in the offset. We need to multiply by the map speed as well. And I'll now try to demonstrate how exactly this is gonna be working. So it's slightly slower, but now let's try to make it like map size equals to, let's say 20. Save. So now I'm gonna be bigger. Okay, and now you see it's moving faster, but from the perspective of the map itself, it moves like relatively the same. So that's the idea. So you just see like how fast it goes here, but if you just make it like 10, it would be moving slower. And if we make it, let's say, even less, like this, in this case it should be moving even slower. So like it now moves very, very slow. So, but it still moves relatively, relative to the map. So I hope that's clear. Okay, and one last thing before we end this video is the collision detection. So you see like currently it just walks through the walls, which is not really the case. So we need to handle this sort of a thing as well. Okay. Yeah. So now we need to define the map target x and map target y coordinates. So let's create the variable map target x. So this is the cell. So we need to what I've been talking about before. So it's all this raycasting is about, like translating the scaled tile back to the map index and translating the map index back to the scaled tile. So here we need to use the formula to calculate the map index based on x and y coordinates, but we can't use the x and y coordinates directly. Instead, we need to scale them, kind of like scale them back. So the formula looks like this. We need to say like player y multiplied by the map size and plus the player x. However, this value as well as this value needs to be scaled. Okay, so we need to say like player y divided by the map scale, okay, and player x also divided by the map scale, like this. And bear in mind the fact that there can be floating point values for to index the array. We need to make sure that it's the integer, so use math.floor here, okay, and math.floor here as well. But before this, so as far as we're calculating the target offset, not the current position but the target, so where we're gonna be stepping the next kind of move. So before considering stepping into the next move, we need to make sure there is no wall there. So here for target map x, here we need to add player offset x to the player x. I'm sorry, just player x should be like this, and player y should be like this. So player x plus player offset x. Okay, and now we need to do the same for the y offset. So map target y, and this time the offset goes to the y coordinates, so we can leave the player x alone, and here we want to say player y plus map offset y. Okay, and yeah, and now here we need to add a condition. So if we move into this, if we are actually moving, so if the key is pressed, if move x is either 1 or -1, and map indexed by the map target x, it should be equal to 0. So only if the empty cell, so if it is equal to 0, then we can pass through, otherwise we can't. And the same copy and the same right over in here, but target y. And if I did everything properly, then now it should be capable of detecting the collision. So let's have a look. Okay, nope, I did something horribly wrong. It just doesn't move through the y coordinate. Okay. Oh my god, why did I use map offset y here? Sorry guys, player offset. I'm really sorry for this. Okay, and yeah, and now you see we have the collisions. Okay, so you see like we're no longer stepping into the walls. Okay, by the way, neither if we go in forwards nor if we go in backwards. Okay, so yeah, yeah, we just stuck at the walls. So yeah, I'll fix this in the moment. Hold on a sec. So in order to take into account the direction, instead of just adding this player offset x, we also need to multiply by player move y, and here we need to multiply by player move x, and now hopefully, yeah, by the way, just forgot one little more thing, so we don't actually need this plus here. Okay, that doesn't change anything, but just to make it clear. Okay, and now Yeah, and now we're no longer stuck into the walls. So we can't walk through the walls while going backwards. We can't walk through the walls while going forwards. And we can slide along the walls. Okay. So this makes this nice effect when, like in the real game, like you just can slide along the wall. And also you see, like I'm pressing forwards, now I'm pressing left button, and we have the smooth transition as been predicted at the very beginning of this tutorial. Okay, so we can move, like we can handle multiple key presses here. So that's how it works in JavaScript. Well, in Python and Pygame that's much easier because you don't really need all of this like directions like 1 and +1 in Pygame. All this multiple button press handling is done automatically, but in JavaScript we need to do this kind of like manually. And by the way, this is kind of basics for really numerous two-dimensional games. So let's say you want to make, I don't know, like a tank game where a tank is like moving around, and if you just press a button it would be shooting to the enemy. So that might be the case, by the way. So this what we've covered so far is very essential basics to really numerous two-dimensional games when it comes to just handling the angle of the player and moving along the angle, and also handling the collision detection. So this kind of techniques might have been used for whatever games that share the same logic. Well, okay guys, so this is it from my side. I hope you learned something interesting out of this tutorial, and in the next one we'll finally start implementing our raycasting algorithm. So the same style of kind of step-by-step instructions. I'm sorry for those who consider this to be too boring. There were lots of tutorials on raycasting like in one video, but for me personally I just didn't get much from those tutorials, and before I went through all of this step by step myself, I couldn't figure out how this works, and that's the reason why I'm making this step by step, a very detailed tutorials for you guys. For if you're a dumb like me in math, in that case, hopefully this would be helpful. And thank you for kind comments in the commentary section. That motivates me to keep going with this sort of a project. Well, guys, this is it from my side. Again, like, thanks for watching. Until the next time, and take care.